A little note about the special cases of side angle side versus angle side versus angle side. So in this case, I am given a side length, the angle between, and then another side length. So the angle I'm given is literally the one between the two given pieces of information. That makes it a side, then angle, then side. As I go around the triangle, I'm given the side, angle, side. This is a safe case. There is exactly one length that spans that gap. There's exactly one triangle to be made here, so when I identify that I'm given this information, I am good to go. Now, if I'm ever given two angles, then I'm also definitely good to go, because two angles define the third one no matter what, because they're always tied by the 180. Now, here's the other special case. In this case, I'm given an angle, and then I'm given a side, and then I'm given another side. Let's say this is 5. But I'm allowed to move this side wherever I want it to be because I have no idea what angle goes there, and I don't know what angle happens where they meet. So in this case, we have angle, side, and then another side. So usually you see it written as side, side, angle, so nobody has dirty words on their videos. Yeah, don't be dirty. Don't do this, right? In geometry, you might have been told that that was an unsolvable triangle, but in trig, we can solve for, it actually might not exist. It might exist once, or it might exist twice. And this is the quirkiest thing about this. So I have to kind of use my hands here to hold this angle in place. But notice that as I bring my 5 side down, I meet the line down here, and I have this possible triangle. It is a solution, with the 65-degree angle. But if I push this side in a bit, it sort of swings down below, but then comes back to the level. And so there is an obtuse triangle that works. Notice that the angle here is obtuse. And if I come back out again, it meets again at an acute angle that's opposite one of the given sides. So this ability to swing in and out means that I might have, in this case, I would have 2 different triangles to solve for. And the math looks a little bit weird for that. But just be aware that when you're given side, side, and an angle, so side, side, and the angle, when you don't know what this side is, or any of the other angles, there's this possibility. Now, if you're given an angle like this, and these 2 sides, you may not even have any triangles, right? There's no way for me to close this triangle with a side length of 6 and a side length of 5 and an angle of 120. So it's possible for them to sneakily give you some information that has no possible solution. Here is the that page in your notes that's related to that exact thing. In this case, they gave me 34 length here and a 26 here. It's never going to reach with an angle of 89. I did my best to sketch the angles as accurately as I could. In this case, I was given a long enough side that it actually made 2 different possible triangles, and I have to solve for both of them. Down here, notice the relationship. Once I find the acute one, I can do 180 minus the acute one to get this, because it makes an isosceles triangle, and the isosceles base theorem says that these 2 match. So this obtuse angle inside the triangle is going to be a linear pair with the base angle of my isosceles triangle. So down here, I'm not sure what's really going on, but I do know that with an obtuse angle as my given in the angle side-side scenario, that I only have one option for a triangle, because if I swing this down to come to the other side, this is now an acute angle and it's not really the 102. So I'm not allowed to pass through that. And there's only going to be one way to close this triangle, if it closes. So I need to know whether sine inverse of sine of 102 over 24 equals a real angle, or if it gives me an error. This is one where it will probably give you an error, and that's okay. You're expecting that because you sketched the situation and you didn't expect to be able to solve it. So have fun with those.